drawn up to this step, up to one side perpendicular to VP. Now it is given that a section plane 45 degree to a horizontal plane and perpendicular to VP bisects the axis. So for that, find out the midpoint of the axis. These are the end points A dash, B dash, C dash, D dash would be here, and D dash is here, apex point O dash is here. Now find out the midpoint, and in top view join OA, OB, OC, OD and OE. These full lines should be there because it's a pyramid, so the slant edges would be there, OA, OB, OC, OD and OE, that is represented over here. Now find out the midpoint of the axis. So at a distance of 25 mm from this XY line, mark a point over here on the axis, and from this axis draw a cutting plane line which makes an angle of 45 degree with XY line. So this angle is 45 degree and this is a cutting plane line. Now find out the points of intersection between this cutting plane line and these edges, these slant edges. Say first is OA is here, so from that point the intersection of OA and this cutting plane is somewhere here, right? Here is the point. So from that point draw straight vertical line from here that will cut OA at this point. So here is first point, then OB, from here draw straight vertical line, from OC here is the point, draw straight vertical line. So here you will get 5 points. One point is on OA, second point is on OB, third on OC, fourth on OD and OE. Now join all these 5 points with a straight line, A, B, C, then D, then E and back to A. So these 5 lines, these 5 closed lines represents the cut portion or cutting lines of this front view to represent in top view. Now this edge, this apex point is removed one, you can erase this one, this portion is to be erased, and this shows the sectional top view. Draw section lines, name the endpoints 1, 2, 3, 4, 5 and draw the section lines in this portion. This section lines represents the sectional view. Write the name of view, it's a sectional top view. This is the front view. Now we have to draw the true shape and side view. So for that, what should we do? So for that, as this is front view, this is sectional top view, name the points on the cutting plane and generators. Say 1 days, 2 days, 3 days, 4 days and 5 days are the points. Now from each points, to draw the true shape, from all these 5 points draw straight lines which are perpendicular to this cutting plane and mark a point at a distance from top view. So measure the distance of point number 1 to XY line, measure this distance, put it over here and mark point P1 over here. Similarly, from 3 days draw a line which is perpendicular to this cutting plane line, measure XY line to P3, put it over here, measure XY line to P5, put it over here, and here is point number P4. So from 4 days draw a line which is perpendicular to this cutting plane line and measure the distance of point number 4. Here is point number 4 to XY line and put it over here. Measure 4 days to this line and join all these points with a straight line like this. And this represents the true shape of the section, and draw section lines like this. And these section lines should make an angle of 45 degree with this cutting plane line, and write the name of view as it's a true shape of the section. I hope the solution of this problem is clear to you. That is example number 4. 3 views, front view, sectional top view, and this is the true shape of this pentagonal pyramid, which is cut at an angle of 45 degree with XY line. You do correction over here. This is 60 millimeter, not 30 millimeter, and here this is 100 millimeter, not 50. But here the scale is reduced 1:2, so here 100, here 60, and here 50 should be written. Now example number 5. The data is given like this. A hexagonal pyramid, 30 mm sides and 60 mm height, has its hexagonal base in vertical plane, a cutting plane bisecting the axis and inclined at 30 degree to vertical plane. Draw projections, sectional views, and a true shape of the section. So here brief data is given like this. A hexagonal pyramid, 30 by 60 on VP, cutting plane bisect the axis at 30 degree to vertical plane. So here again the base is on VP, so first we have to draw a hexagon above XY line like this. So draw a hexagon above XY line of side length 30 millimeter, and its top view would be a reverse triangle like this, because it is given that its base is on vertical plane. So this would be front view and top view of the given position. Draw axis of this solid, and here cutting plane line bisects the axis. So find out the midpoint of this cutting plane, this axis. It would be somewhere here, and from that midpoint draw a cutting plane line at an angle of 30 degree to XY line, because for top view this XY line is VP. So this is the cutting plane. Now this is the removed portion. You can see here, if we cut this, this is removed portion. So erase this one. Now let me draw the solution of this problem, how to draw the true shape and sectional front view of this hexagonal pyramid. So the first steps we have drawn. Now this is the portion retained with us that we have drawn, and these edges would be there. Here would be the edge, and here also the edge would be there, and this is the portion. Right? Similarly, in top view hexagon is there. I hope it's visible. Yes. Now find out the points of intersection for this cutting plane and name the generators. Here is apex point O. Here 1, 2, 3, 4, 5 and 6. Here apex point O is there. So here of course dash marks would be there in the front view, and here 1, 2, 3, 4, 5 and 6 points are there. Now find out the points of intersection between this cutting plane line and the generators. As we know, this is a cutting plane line that you should represent very clearly in your drawings, because it's very important. And XY line is here, and the angle between XY line and this cutting plane line is 30 degree. This angle is 30 degree. You can represent in diagram as well. Right? Now the points of intersection between cutting plane and O1. O1 is here, and here P1 point would be there. That is intersection of O1 and cutting plane. Right? Similarly, here point number intersection of O2. Say here O2 is there. As we have erased this, light lines should be there to represent the erased portion and to find out the generators. P2 means O2 and cutting plane. Here is point number P2. Then O3 and this cutting plane. Here is point number P3. O4 and cutting plane P4. O5 and cutting plane P5. O6 and cutting plane, that is P6. So we have identified 6 points, and from all these 6 points draw straight vertical line. Before that, let me draw top view of this solid, front view. In front view, these edges would be visible, that is O dash to 1 days, O dash to 2 days, O dash to 3 days, O dash to 4 days, like this. As it's a pyramid, these slant edges can be represented by the straight lines as shown over here. Now P1 point is here, it is on O1, so from P1 draw straight vertical line that will cut O dash 1 dash. Here is point number O dash, right? Intersection of O dash 1 dash and this vertical line is this point. So mark that point over here, that is somewhere here. So and that is point number P1. Similarly, point number P2, from here P2 draw straight vertical line, so that will cut P2 at this point. Then P3 is here, from that draw straight vertical line that will cut O3 at this point. P4 is here, so from that draw a straight vertical line that will cut O4 dash at this point, right? P1 to P, all 5 points, vertical line from all 5 points that will cut respective slant edge at the points from P5 and from P6. So here is point number P5, here is point number P6. Then join this P1 to P6, all the points with the straight line, as it's a pyramid, no curvature shape would be there. So irregular shaped hexagon would be there, irregular polygon having 6 sides, so it's a irregular hexagon like this. Now you can darken this outer portion as it's visible, the base is visible, and the apex point is removed portion, so you can erase that internal portion as well, like this. This internal portion is to be removed because the apex point is not there. And join the slant edges, say these slant edges would be visible. You can slightly darken those slant edges to clearly represent the drawing. And in this internal, this cut portion, you have to draw the section lines at an angle of 45 degree with X value. Hence this represents the sectional front view. You can write here the name of view, it's a sectional front view, right? Now how to draw the true shape? Yes, the same steps would be there. Name the points P1, P2, P3, P4, P5 and P6 over here, and from all these points P1, P2, P3, P4, P5 and P6 draw lines at a perpendicular to this cutting plane line, like this. From P1, P2, from P3 and P4, P5 and P6. From all these points, lines at an angle of 90 degree to this cutting plane, means this angle is 90 degree, you can see here. Now measure the distance of all these points from XY line to P1, measure this distance, XY line to P1, right? From P1 draw an arc on this line, so here point number P1 would be there. Then XY line to P2, this one, XY line to P2, this one. So XY line to P2 on P2 somewhere here. Then XY line to P3, P3 somewhere here. XY line to P4, measure this distance, it is equal to XY line to P1, so it is over here. Then XY line to P5, take in sequence to avoid the errors. XY line to P5, an XY line to P6, this distance, and from P6 cut it over here. So we have identified 5 points and join all these 5 points with a straight line, as it's a pyramid. So these 5 points should be joined like this, and this represents the true shape of the section. And in this true shape you have to draw the section lines at an angle of 45 degree with that cutting line. In examination you have to use the pencil, dark pencil and light pencil. It's a true shape irregular hexagon. Insert the appropriate dimensions. Say height is 60 millimeter. This is bisecting, so this distance would be 30 millimeter, right? And this angle is 30 degree that we have inserted. In examination, students forget to insert the dimension, so you should take care about that. Then erase these lines, are not necessary. So I hope the solution is clear to you. This is the solution for given problem. Now hints for sections of solids. Some hints which are useful to solve the problems, that is mentioned over here. When the axis of the solid inclined any of the projection plane, it is given, then first assume the axis is perpendicular to that plane. In any problem, if it is given that the solid is inclined to some plane or any, then we assume that it's perpendicular to HP. Suppose it is given that the axis is inclined to VP, first we assume that it's perpendicular to VP. Then draw the projection in simple position, either it's front view or top view depending upon the given plane. If the angle with HP is given, draw top view. If angle with VP is given, draw front view first. Then top view first if the axis is perpendicular to HP, and front view if the axis is perpendicular to VP. Then change the position of the view to the given inclination. Tilt front view if the axis is inclined to HP, and tilt